Construct a PDA for A per n, B per n, where n greater than 0. It means that minimum string is A, B. Or you can have any number of A's with at least one A followed by same number of B's. So here let us see the logic here. So this is your A part. So where you will have n number of A's. For each A, I'll be pushing a representative which is A into the stack. So once I complete processing A's, I will have n number of A's. And once I start B, I'll pop the corresponding one A from the stack. So for every for every B, I'll be removing one A from the stack. So once I process the input string, if it is of the form A per n, B per n, then I will be removing all the A's and I will have the initial stack symbol which I had at the beginning. So this is the logic. Now here initially my PDA will be in the start state Q0 and I have the top stack symbol Z. And this is my first input symbol which is A. There should be at least one A, so A will be the first input symbol. So delta of Q0 on AZ, I have to push the representative. So Z is at the top previously. Now I am pushing A. So now A is my top of the stack. So I remain in the same state. So this is for the first A I will be doing. So now my top of the stack is A. I am in the same state Q0 and if I get any more A's, I'll be pushing one more A that is into the stack. So previous A and again one more A and I remain in the same state. So this is the delta which processes the remaining A's. So once I complete processing all the A's, I have n number of A's and below I have Z. So now once I get B and I am still in the state Q0 and my top of the stack is A, I'll start popping it and I have to change the state because once I get B, I again should not get A. So I'll be changing the state to indicate that I have started processing B and this A has to be removed. So it is epsilon. This is for the first B. Now my state is Q1 and I am getting B for the remaining B's and my top of the stack is A, then I will again remain in the same state and pop the top stack symbol. This will be processing all the B's which I am encountering. Once I complete the processing of the input string, I will be having epsilon. And if the top stack symbol is Z, it means that I have equal number of A's and B's. So by which I will be indicating that by going to the final state QF and I keep the top stack symbol as it is. So this is your delta for your PDA for this language. So it is represented here. So initially I am in the state Q0. So for A and top stack symbol Z, I will be pushing A. So my delta is A, Z. I will be having AZ. So this is for the rest of the A's, A. And once I get B, I change the state from Q0 to Q1 and B and the top stack is A and my I have to pop it. It means it is epsilon. So now for the rest of the B's again BA epsilon. So once I get empty string means once I complete the processing of the entire string and if my top stack symbol is Z, I retain the Z and I go to the final state. So this is my transition diagram for your PDA for accepting the language A per n, B per n greater than 0. So let us assume that I have more number of A's than B's. So it means that once I complete the processing of B's, I will not be having Z at the top, but I will have A's at the top, which means that Q delta of Q1 BA. That means the delta of Q1B and I will be if you have extra A's. So delta of epsilon on A that is not defined, which means that so for whichever the configuration my uh, machine is not been defined, which indicates that the string is rejected. So if there are more number of B's, it means that I have shortage of A's. It means that I will not be getting, I will not be getting the delta for, I will be in the state Q1 and I have B and input is B and I get the Z. So that delta is not defined. So in that case again the machine will be halted in the or halting in the reject state. So this is the construction of PDA for A power n B power n. Thank you.